Okay, so last time we finally got this microcontroller programmed and we got the LED turned on, and that was awesome. Now we're gonna make it blink. Since we're using assembly, it's gonna be a little bit more complicated than if we were doing this in Arduino or something like that, because you have to do everything very manually. But at the same time, it's not that hard. So we're gonna go through this and we're gonna learn mostly about how delay loops work and figure out that structure so that we can, because we're going to use that all over the place. And that's really all we need to do is we need to turn it on, delay, turn it off, delay, turn it on, delay, turn it off, delay. So first I want to go through and introduce some of the new assembly instructions that we're going to be hitting. And so I'm going to go through this line by line, and then I'm going to go back and talk about the structure and what is actually happening from a higher viewpoint. So with that, let's get straight into the code. You're going to see that basically the first 9 lines of code we've already discussed. You already know how to configure it, you know how to initialize it, and you can see from the move literal into W that we're enabling the GPIO and also setting it as an output, and so all that sort of stuff should be straightforward. Now, the actual program itself is from 10 to 15. So under 10, you can see where it says loop, and as much fun as it'd be to say, oh, loop, all I have to do is put in the loop command, that's actually not a command, that's just saying this is the loop section. So from 10 to 15, that is a loop, and you can see BSF, which is bit set F. So it's saying basically in the GPIO register, bit GP2, set that bit. So basically turn it into a 1. Then you're going to call that delay routine. Then you're going to have bit clear F in line 13, BCF, and then you're going to take bit GP2 of the GPIO register and clear it or turn it off. And then you're going to call that delay in line 14 before hitting 15, doing that go to loop, and bam, you're up at the top and you're doing that loop forever and ever. That's pretty straightforward. So it gets a little bit more complicated once we actually get into the delays. So let's go down and we're going to look at some of these commands. And in line 18, we have move literal to W, and that's something we've already discussed, where you take a literal, an actual number, and put it into the working register, the W register. And in this case, we put decimal 162. We'll go over that afterwards. First, I want to go through this, but that 162 isn't a completely random number. Then the next line is where we do move W to F, and that is where we copy the value of W into a register, F, and in this case, it's register 10. And then we do the same thing where we copy that 162 in line 20 to register 11. So we're getting everything set up, and then in line 21, we're actually doing the delay loop itself. So this is a new command, and it's kind of a long, weird, random looking one, DECFSZ, decrement F, skip if 0. Now, that's actually pretty straightforward if you take it apart completely. So what you're doing is you're decrementing F. In this case, the operand is 10, register 10. So you're decrementing whatever value is in 10, and then checking, is that actually a 0 or is it still have a number? So if we start at 162 and we decrement it to 161, it'll check to see, oh, it's been decremented, it's 161, it's not 0. And then since it's not 0, it is not going to skip the next line. So since it's not going to skip the line, it's not going to skip line 23. Since it's not 0, it's going to go 23, say, oh, I got to go back up to the top, goes back up to line 21, jumps down to 22, takes that 161, changes it to 160, says, hey, it's still not 0, jumps up to 21, and does that over and over and over again. Now you'll notice in line 22, the second operand is F. And the reason it's doing that is because it's taking that F register, it's decrementing it, and then putting that value back into the F register. That is something where you could take the value, decrement it, and then load that new value into the working register, but we want to keep it in that F register so it keeps on decrementing. Because if we load it in the working register, it would just be going from 162, loading a 161 into the working register, 162, loading a 161 into the working register, and it would have absolutely no point whatsoever. So since we're doing that and we're going through that 162 and we go back through, finally we're going to hit 0 and we're going to skip line 23. When we skip line 23, we're going to jump to line 24, where it's the exact same command, but instead of reducing the value in register 10, we're doing it in register 11, which is also 162 right here. So now this is where it gets a little bit more complicated, because it's going to go through in that 162 and it's going to go all the way down to 0. And then it's going to jump down and it's going to take that 162 in register 11 and decrement that to 161. Then it's not going to be 0, so it's going to go to the delay loop, bumping up to the very top. Now once it goes up to the very top, it's going to go check, decrement file register 10, which is 0, and then check to see if it's 0 again. But the way computers work, since this is an 8-bit microcontroller, it goes 0 to 255. So if you do 0 minus 1, it's not -1, it's 255. So what's going to happen is you're going to have that 0, you're going to decrement it, and it's going to pop up to 255. It's going to check and say 255 isn't 0, so it's going to do that loop all the way down from 255 to 0 again before going down, checking register 11, saying, okay, now I'm at 161, drop it to 160, jump all the way back up to the top, loop 255 times with 10, go down to 11, do that one more time, 10, 255 times, down to 11, and it's going to do that a lot. And since this works so quickly, this is all happening very, very fast. And this is all busy work. This is something that just telling the microcontroller to do something, to give it time to be able to say, all right, that's the amount of time I want. And once it goes through all of those loops, all of those times, then it jumps back up to line 14 where you've called the delay and you've been returned. Now you're done. You go to line 15, you loop back up to line 15, you do the bit set F, call that delay, go through all that rigmarole, go down to bit clear F, call the delay, do all that rigmarole, go back up to the loop, and that's what it's doing. So that's basically the entire structure of this program. And again, that delay, it can be kind of confusing because it's all nested in there and because you have to count that register 10 so many times before you decrement register 11 at all. And it just seems weird at first and seems like a whole lot, but again, it's happening so fast that you have to do it a whole lot of times to make it slow enough that as this is turning on and off, we can actually see it. Really quick, I do want to mention why we chose 162. So Sergey figured this all out, and when he said, I want this to oscillate a couple of times a second, and this is not very precise. We don't need to have it exactly a certain speed. We just need it approximately 1/8 of a second on, 1/8 of a second off, so we can see it. And that's really it. This is not exactly 1/8 of a second, but in general, we realized that if we had a 162 times 255 times the 3 cycles that it takes to do the because a go to instruction takes 2 cycles, and the decrement takes 1 cycle, and also take the fact that each cycle, you can run 1,000,000 cycles per second. All of those added together comes out to about 125 milliseconds, approximately 125 milliseconds. So that's why we chose that 162. Now again, it's not going to be precise because the first time we do that register 10 decrement, we're starting at 162 instead of 255. So this is a bit hand wavy, but we don't need that sort of precision right now. In a couple of tutorials, we're going to be making music using a speaker, and then you need to get that pitch exactly right, and that's when it's going to really matter. But for right now, we're not worrying about it. So I'm going to load this really quick and show you what you should be seeing when you get this. Okay, so it's loading up right now, programming, and that's it. So that's all you get, is that blinking LED. So all of this is every time it's turning on and off, it is waiting a huge amount of time, according to the microcontroller, turning it on, waiting a huge amount of time, turning it off, back and forth, and it's just an endless loop. Sergey, when he did the written tutorial, he put a homework assignment in there. And that homework assignment is to make it so you have one of these blink on, and while the other one's off, this one turns off, that one's on, and basically have them oscillate. Now, I highly recommend that you do this. So as you're listening to this, hopefully you've been following along, you have all of these parts. We tried as hard as we could to make this as inexpensive and easy to follow as possible, because only by doing it are you going to learn it and intuitively understand it. Because honestly, Sergey put this together, I did it, and okay, I kind of learned some things, but it wasn't until I was doing it myself and not just following along with these tutorials that all of these commands really sunk in, and I got a better intuitive understanding, and everything started to click. So he likes to give these homework assignments because he's a former professor and he understands the necessity of actually doing it to learn it. So before you move on to the next tutorial, once you get this working and you get that LED blinking, make your own modifications so that you can have both of them blink alternatingly. You can go check because he's got the solution, he's got a solution for doing that. And you can see if yours is similar to his. It doesn't have to be. It can be better, it can be worse, whatever. As long as you're doing it, you're gonna learn. All right, I'll get off my soapbox now. If you like this video, give it a like. If you have any questions, leave it in the comments on YouTube or on our website, circuitbread.com, and we'll try and get back to you as quickly as possible, and we'll put it in one of our FAQs. Subscribe to our channel, and we'll see you in the next one.